wanted to just quickly introduce Heidi. She's a professor and past chair of computer science and information technology at Western New England University. She has a really interesting path into computer science. I think she might be our first DLS speaker with an undergrad degree in animal science. I don't know for sure. So she worked after her undergrad managing a dressage barn. Did I say that right?
You said that right, yes.
And after that, switched in computer science and did a master's and a PhD in CS and engineering. She's been a CS educator for 21 years and started by teaching adult working professionals for 11 years before switching to teaching undergraduates. For 7 years, she's been one of the leaders in NSF-funded HFOSS projects, Humanitarian Free and Open Source Software, aimed at teaching computer science faculty members how to integrate HFOSS into their classrooms. She's taught over 100, including me. I went to one of the sessions, at over 70 schools, which has impacted over 1,200 students. She was the co-chair for the open source track at Grace Hopper, was a finalist for the Red Hat Women in Open Source Community Award this year, and is a regular presenter on HFOSS at SIGSI. And this year also the Business Insider named her as one of the top 26 women engineers. Pretty cool. So I'm really excited to learn more about your work. Thank you.
Thank you.
So thank you. So I'm going to talk today a bit about humanitarian free and open source software, better known as HFOSS. Let me see if I can get a little read of the room, as they say. How many people can list off the top of their head 3 open source software projects? Okay, good. Has anybody contributed to an open source software project? Okay, good. Is anybody a committer for an open source software project? Oh, good. What?
3.
Pardon?
Oh, what?
Pardon?
I thought you said 1. Privacy Badger. It's a.
Oh, yeah, I know. I have it. I've actually got it installed. Privacy Badger. Good. And back there? Was somebody a contributor, a committer back there? Oh, good. Okay. All right. So to give us an idea about where we're headed, I want to talk a little bit about why FOSS and then what is HFOSS. I'm going to go on and talk about the use of HFOSS for learning, because my area of interest is, my area of research is student learning within HFOSS communities. I'm going to talk a bit about what students can do, and I'm going to give you some examples of what students have actually done. And then we do some research on student learning, and I'm going to tell you a little bit about what we've learned about from the research, and also talk a little bit about where we're going forward in the research direction. And if we have time, I'll talk a bit about how to get started. So open source software, free and open source software, I'm going to call it FOSS, right? Opensource.com, which is a leg of Red Hat. How many people heard of Red Hat? Yeah, okay, good. First $2 billion open source company. They basically package Fedora and support it and make $2 billion a year. Okay, that gives you some idea of the size of FOSS. So open source calls it source code available for modification and enhancement by anyone. If you go look at Wikipedia, Wikipedia takes a slightly different slant and talks about the license. Okay? And the license is important because the license is what makes open source open. It's what defines what we can do and how we can do it with the software. And you may be familiar. How many people got Android phones? Yeah, okay, you're using open source. Apache, since they were starting to keep data, Apache's been the most popular web server out there. I looked yesterday, it might be running 47%. So it's still very popular. Linux is a common one. And open source is used across domains. So Firefox, LibreOffice is what is presenting this presentation to you now here. R, people use SPSS or R? Yeah, okay, so you're familiar with this, okay? And then the GIMP is the Photoshop equivalent. Okay. To give us an idea of the magnitude of what we're looking at, Accenture's done a recent study that shows that 98% of enterprise companies are using open source. Okay. Black Duck is a company that spends a lot of its time looking at and analyzing and producing reports on open source software. In 2015, their survey showed that 78% of companies are using FOSS in some form. I couldn't find the percentage number for 2016, but 65% of the companies that they surveyed contribute to FOSS, and 67% encourage their employees to contribute to FOSS. Right? So there are people that are getting paid to work on FOSS within their company. And the reason is, back to the 78% of companies that are using FOSS, those companies want their FOSS to support their companies. If they pay their employees to work on the FOSS, it then supports their desires. So that gives it, so FOSS is pretty darn widespread, widely used, okay? And it is growing. The use of FOSS is not going to go down as we go forward. When I start looking at FOSS, I think of it for learning. And there's some features of FOSS that make it very attractive. One is everything's accessible. I can look at the code. I can look at the artifacts. I can go find the bug report for something. I can find out if something's been tested and how. I can look and see how the rationale behind why a design decision was made. Now, it may take me a little bit of looking to find that, but it's all there and it's all open and it's all accessible for learning. Okay? The second reason, which maybe is actually the first reason, is if I take students and involve them in an open source community, they can then learn from the community. There's actually a technical term for this called legitimate peripheral participation. It's learning by apprenticing yourself within a community, okay? If I stand up and I'm the instructor for a course, I could be a bottleneck. If I can involve students in a community of even 30 people, they now have 30 professionals from which to learn from. There's lots of opportunities. Students can do all sorts of different things. And students typically like to contribute back, and that's a positive. Now, when we think about it, when I think about learning from the community, you'll notice that I say learning from the community, not learning from a software project, because open source is all about community. You might think it's about the software, it's about the community that develops the software. So now let's put the H on the front of FOSS. And for humanitarian FOSS, we use a fairly large umbrella to define what this means. It is basically software that benefits the human condition. And so it could be Ushahidi. Ushahidi was first used to track voter irregularities in a South African country. FOSS is microfinance. Sahana is disaster management software. OpenMRS is software that was started in 2006 to track AIDS patients in, I think it's Zimbabwe. Okay. Oh, and this, the lower right-hand corner is the GNOME accessibility logo. So this is how I got started. And it was a startling start. You may remember 2004, Sri Lanka got hit by a massive tsunami. And Sri Lanka doesn't have a lot of resources innately. It did not recover very easily or very well, and it was still working to recover in 2005. In December of 2005, the gentleman who was maintaining our labs, I was at Trinity College at the time, upper left-hand corner, Trishan Delanarole, he had gone home for Christmas to Sri Lanka. And he came back, and he came in my office, and he said, "You gotta get involved in this project. You gotta get involved in this project." And I looked at the 40,000 things I had to do, but he came back, and he came back. And I finally said, okay, fine. I had 2 students. They wanted to do an independent study. So I said, here's this project called Sahana. Sahana is the Sinhalese word for relief, and it helps you manage resources in the case of disaster. For instance, you don't want to go send your doctor who volunteers to lay bricks. That doesn't make sense. You want them to go provide medical aid. So I said, okay, fine. I took the 2 students, I sent them off with about 0 help. I said, go download and install this thing and report back if you can do it. And they came back in about a week and they said, hey, I can do this. And they took me into the lab and they showed me. And I said, okay, that's cool. And I said, now go download and install the development environment, because that's not the same thing as installing the product. And they did that, and they came back and they said, yeah, we got it down. Here, come look. And so I said, okay, this is cool. And so I said, can you make a change to the code? And they went off and they made a change to the code and said, yeah, we can make a change to the code, look. Then I thought, okay, this is kind of cool. Well, this student, the lower left, is a gentleman called Jonathan Damon. Yes, he is a Red Sox fan, and his father is a Red Sox fan, right? Jonathan Damon and another student, a Bard College student who completely volunteered his summer, spent the summer working on a volunteer management module for Sahana. At the end of the summer, the Sahana team was so impressed with the work that they had done, they flew Jonathan Damon from the East Coast to the West Coast to San Diego, where they used that volunteer management module to register all 800 participants in the Strong Angel 3 disaster and pandemic simulation. 200 of the top tech companies on the West Coast kicking the tires on their technology, what would happen in a disaster, and this is my student. And sitting on his left is Deborah Burnson, who is the head of the San Diego Red Cross. Standing up behind is, I believe that's Chamindra De Silva, who is the lead of the Sahana project. He's sitting across from Eduardo Jazierski. He, at the time, was the architect for SSE, which is the Microsoft equivalent to RSS. The picture I don't have is showing Jonathan standing there talking to the worldwide head of the IBM crisis response team. So this happened, and I thought, whoa, this is kind of cool. And I thought, students can learn in this sort of an environment. Okay. So since we built on this was not done entirely by myself. I worked with Ralph Morelli from Trinity College. You may know him. He is now doing CS Principles with App Inventor. And we had students working on a variety of projects. And what we found is students like to do good, right? And this is an example showing you a couple of pictures that were taken in, I do not remember what country. It is, again, a South African country. OpenMRS needed a touch screen interface, and students at Trinity College developed it, and they very kindly took pictures and sent them to us so that we could see what was happening. Okay. So students like to do good, okay? They like to contribute back to society. For instructors, involving your students in HFOSS is a really good way to accomplish a service learning component. Students get involved in real-world projects with real-world complexity. They get exposed to 500,000 lines of code, 1 million lines of code, and they do it while they're still in school, before they're out, right? So you can help guide the learning process. This happens to be just part of the database schema for OpenMRS. And they learn within a professional community. They learn from people that are around the world. I had a student involved in a project, and their team meeting was in India. The project's team meeting was in India, and it was at, I think, 5 p.m. in India, and he used to just stay up all night and see the sunrise because he wanted to attend the meetings which were 5 a.m. our time. Okay. And so they get exposed to a whole variety of different people. In my experience, I do not have hard data to support this, I've also found that humanitarian FOSS projects, due to their altruistic nature, tend to be very welcoming of students. My personal opinion is I do not want to put a student into a project where they're going to get nailed or yelled at for doing something wrong. I would much rather be in a community that says, you know, that's not quite right, can we try it a different way? Okay. And so we have very welcoming communities in HFOSS. Let's talk about what students can do. All right, so Paul Simon, folks. Yeah, I got a few people who know Paul Simon. 50 Ways to Leave Your Wet Lover. Just slip out the back, Jack, right? You with me? Okay. So we actually sat down and did this. This is work that we did probably about 10 years ago. And we wanted to know how many different ways could you contribute to an open source project, right? What can you do? Not you, but what can students do? And we came up with a list that's actually over 150. And John Dougherty, got hold of it, and we actually wrote lyrics and recorded it. So it has things like "Just squash the bug, Doug." It's, yeah. But what you see here, right, the last thing on the list is coding. Students can do lots and lots and lots of different things. Just using and evaluating software and giving feedback back to the community can be huge, right? Things like philosophy and politics. Oh, privacy and security, that is so much of a need. Privacy Badger, right? It's a huge need today, and many open source projects don't have people that are focused on that area. Okay. All right. So I thought I would show you some of the things that students have done so that you get some idea. This was work that was done in 2010, so it's a little out of date. The picture's more recent. OpenMRS. OpenMRS is the world's leading medical record system, okay? And I mentioned that earlier. Started in 2006. It's almost 4 million lines of code, and it's 4 million lines of just about any kind of code that's out there. Someone working with OpenMRS said if there's 50 different ways to create a pop-up window, OpenMRS uses all 50 different ways. So it's not trivial. It's got over 5,500 commits, 300 contributors. It's large. It's a big project. Okay? So my students wanted to work with this. It wasn't quite this big back then. This is current data. It was more like, I don't know, 1.5 million lines of code. Not that it makes a huge difference. They needed to get the development environment installed, and they were having difficulty. What tends to happen in the open source world, if you're a developer, is that you get started on a project, and when the next upgrade or release of the tool that you're working on is released, you incorporate it into your current development environment. And so you are incrementally updating your own development environment. And it works great. The problem is that if you're somebody new coming in from the outside, how do you get that same development environment set up? It's difficult. So my students tried to do this, and they couldn't get it done. They couldn't get it done. And the problem here is, if you can't get the development environment installed, nobody's going to contribute because they can't figure out how to make a contribution to code. So they spent time, and what they actually did was they used a virtual machine. And they installed the first tool, took a snapshot. They installed the next tool, took a snapshot. When they hit a point which they couldn't go any further, they backtracked and installed a different tool. So they had this tree of tool installations, and they finally figured out the right path through that tree that would allow them to install the developer instructions. And they contributed it back. They turned around, they put it back on the OpenMRS website. Todd Binger is one of those students. Okay? John Pulaski was also one of those students, but his name got overwritten by Wycliffe, who came along later and upgraded those development instructions. This is a picture of, from the left, Justin Duperi. Todd Binger is standing in the middle. John Pulaski is standing on the right. And they're actually doing their final presentation here. You might want to remember Justin Duperi. He's going to show up again, and you'll see John again. Another project we worked on was Caribou. Caribou is a GNOME accessibility tool. When I involve students for probably 4 or 5 years, when I involved students in humanitarian projects, I stayed within the GNOME community, and I stayed within the GNOME accessibility community because there's a series of different tools that are all supported by the same community. So I had one community to interact with, but there were a variety of different applications I could work with. Caribou was one of them. It's an on-screen keyboard. Much, much, much more approachable than almost 4 million lines of code. So students downloaded. It took them about 2 weeks to get the thing downloaded, installed, and up and running because the make files and the CMake files were non-trivial. So even though the code was simple, getting it up and running was difficult. And the first thing they did was they looked at this keyboard and they said, now remind you, this is 2010, you can't surf the web. And if you look, there's no // so you can't type in https://. It's not there, you can't do it. So they said, oh, you know what, we can make this, we can add this. So they did a couple of additions there. They added the / they added a num key to get you to the numbers, okay? A way to hide the keyboard, because if your keyboard is taking up major screen space, it's hard to see what else is on there. And then they renamed the tab and the shift key to make it a little bit more visible. And this took us a couple of months to accomplish. It took us, oh, I don't know, less than 50 lines of XML code. They didn't even have to touch the underlying Python code. Students also created a programming keyboard. And so what you see here is if you're a coder, having to switch back and you're a user with a disability where you can't use a hardware keyboard, having to switch back and forth from the numeric keyboard to the math keyboard where you can use plus and minus and all that, that's difficult. So they created one that had all of that showing at the same time for programmers. I was fairly new to open source at that time. This is 2010. I'd been doing this for, I don't know, 4 years. And I had a friend, Mel Chua. No, Mel? No, okay. Mel Chua, she is just finishing her PhD in engineering education from Purdue. And she was in the Red Hat OSAS community team. And she, at the time, had come and visited me for a while, and she said to me, you know, you should take your students to the Boston Summit. And I'm like, what the heck is the Boston Summit? And she said, the Boston Summit, the GNOME team has what they call a Boston Summit, and it runs every October, and it runs over your Thanksgiving holiday, which is our Columbus Day. And it's in Boston, except when it's in Toronto, and it's still the Boston Summit, but it's in Toronto, because it is. So she said, take them to the Boston Summit. I didn't know what it was. I didn't have an idea. I didn't know what an unconference was. I said, great. I put it to my students. They said, yeah. I had 4 students. They were ready. Put them in the back of the car. Now, I'm in Springfield, Massachusetts, so Boston to me was like an hour and a half down the pike. It was a fairly low barrier of entry. We get to Boston Summit, and we are in a room with about 200 GNOME developers. And they're doing the unconference thing. I didn't know what an unconference was. Mel nudges my students. Go put Caribou up on the keyboard, up on the chalkboard. They're like, okay. And they walk up and they put Caribou up on the chalkboard. No more than an hour later, they are in a room like this, a little bigger than this, presenting the work that they had done in their class to 45 professional GNOME developers. They get done, and somebody took them aside and gave them a 45-minute tutorial on how to do that with SVG keys. And I get in the car on the way back, and I hear from the back seat, these are seniors, right? They've been in school for 3.5 years. I hear, thought I knew what computer science was, but I didn't have a clue, right? So these are the sorts of experiences that don't happen every time, but when they do happen, I think, wow, there's a student that walked away changed because of their involvement. Other projects we've worked on, Cheese. Cheese is a webcam, and students have made some modifications to Cheese to allow it to do enhancements. So things like mimicking magnifier to make the text very large. Also adding color filters, because for some people it is visually easier to see blue on yellow or yellow on blue than it is to see white on black, and vice versa. This is an interesting project, the Spatial-Temporal Epidemiological Modeling System. My students found this, by the way. They went off and wanted an HFOSS project and came up with this one. I said, great. STEM models how diseases move across the country. Pictures may be better here. So here you see a picture of the United States. The brighter colors are counties that are more heavily infected with, I think this is swine flu, I'm not entirely sure. Over time, what will happen is this will progress over time and show you how this disease would grow across the US over time. This is swine flu, and what you see is when you roll your mouse over a particular county, the tooltip pops up and it shows you the county it is, and it gives you the population in the area and things like that, right? Okay. What else would you like that thing to show you?
How many people are infected?
Yeah, exactly. My students looked at that and said, you know, it would be really helpful to know how many sick people we have here. So they did 2 changes, right? They modified the mouse over tooltip to show how many are infected, and in addition to knowing how many are infected, it would be really good to know at what date and time the map was generated, so you had some ideas to the recency of the information. And they did this. Now, 2 slides ago, or 3 slides ago, I showed you it had almost 750,000 lines of code. They did this within a 15-week time period. Are you going to learn 750,000 lines of code? Not in my lifetime, right? They did this by working within the community. They became part of the community. They became involved. This particular community does not use IRC. It used Skype calls. They were on every weekly Skype call. And when they decided to do this, they turned to the community and they said, we would like to help. We would like to accomplish this, which the community had said they wanted because it was on a bug report. And they said, how do we start? The community turned around and said, oh, go talk to this person. They know something about this. My students created communication with that person, and that person said, oh, go look at this class in this file. So they narrowed, within 2 days, they narrowed 750,000 lines of code down to about 100. That's manageable. Mousetrap. Mousetrap is a project that Joni Diggs is the head of the GNOME accessibility team, and she approached me and she said, you know, I've got this project. It's really kind of a cool project, but I don't have there's nobody maintaining it at this point. Mousetrap is a project that uses a webcam to track user head movement. So if you raise your head, the cursor goes up. If you lower your head, the cursor goes down, right? It's for people who have difficulty using a hardware mouse. It was started in 2009 as a Google Summer of Code project, and it's got a lot of XML code and some Python code. I don't know if these figures are exactly current. So we entered in the partnership there, okay? And I'm one of the maintainers of this project, and Dr. Jackson is one of the maintainers of this project. If you go look at this project, we haven't done much, because I know you're going to go look. Yeah, no. And part of the problem that we haven't, part of the reason we haven't is it uses open CV libraries, open computer vision libraries, and there's a fair bit of intricacy there. We're stuck trying to figure out how to get the left blink to cause the left mouse button to click, because that's how you click if you're using Mousetrap. Okay. This was 2014, and in 2014, the Boston Summit was actually held in Toronto. And by now, we had the understanding that this could be a learning experience for students. And so students went, okay? And these, again, are all seniors. What they learned this time, and I didn't get to go with them this time. They went on not quite on their own. We did have a chaperone with them. But they did 2 things. One thing they did was they sat down and they worked with somebody with Joni Diggs, the team lead, and they built a prototype user. What does the typical user for Mousetrap look like? And that was extremely helpful for them for getting an idea as to how Mousetrap should really work. The second thing is that Karen Sandler, who was at that point head of the GNOME Foundation, she's now chief legal counsel for the Free Software Foundation, came and gave them an hour tutorial on software licensing, right? Just because she was there and she liked my students. Okay. This case, this is Justin Duperi. You saw him some 20 slides ago, right? He's again back to 2010. Justin Duperi is really interesting. I had him for a year. I saw him join no less than 4 different open source communities during that time. Figured out how to make his way in, joined them, was just really good at understanding how the community worked and how to interact. So he was working with the multi-level healthcare information modeling system, and he came into my office, and he was sheet white, and he was shaking. And that's like not a demeanor that I like my students to have. So I said, sit down. Take a deep breath, and he sat down and he said that he had just received an email from the head of the World Health Organization who wanted to fly him to South Africa for the annual meeting for MLHIM in 3 weeks, and he didn't have a passport. And we didn't, I regret that we could not get him there, but that's an opportunity that changes lives. right? And again, it doesn't happen all the time, but when it does happen, it can be phenomenal. All right, so what did students learn? I asked students to write reflection papers at the end of the semester, and these are some of the comments that I've gotten out of the reflection papers. That they understand now when they get done about writing good self-documenting code. Oh yeah, the whole comments thing. Yes, you have to comment your code. And you had to learn how the code worked, right? You couldn't just make a little change and see what it did, and make another little change and see what it did. You had to actually sit down and look and figure out how the code worked. That things change, deadlines change, specifications, database changed. I had a community that took a left-hand turn and completely decided they were going to use a different software architecture halfway through a course. So they learned how to cope with that. Okay? How to find their place in a real-world organization. Oh, and professional contacts are huge. Okay. All right. Okay, so that's some of what the students have done. We've been studying this for a while. And the form of our study is a pre-post test, okay? And we were looking at how do students learn and what is their impression of their learning within this environment. Oh, and by the way, I am NSF funded. I've been NSF funded to do this work since 2009. I'm on my 4th NSF funding for this type of work. NSF loves the idea of HFOSS because students are learning, but yet they're contributing back. All right, so our study was constructed to look at 3 basic things. One is motivation. Right? So what is the impact on a student's motivation from being involved in an HFOSS project? The second is learning. What sort of computing learning do they do within the project? What are they getting out from like a technical standpoint? And then lastly, what impact does this have on their major and on their career? And these are just 3 examples of the types of questions that we ask. They're not actually questions, they're Likert scale, agree or disagree. Okay, so strongly agree is 5, strongly disagree is 1. All right. The study context, I have more data than this, but this just happens to be a good summary of where we've gotten so far. We have a series of data between 2006 and 15 with a bunch of different institutions that are running different courses and additional data correction. See that POSSE thing? That's a Red Hat originated software workshop for professors. Professors Open Source Software Workshop. Red Hat founded it. I went to one of the first POSSEs. Part of the NSF funding that I received, a team of us, I'm also working with people from Drexel University and Nassau Community College. We've worked to add the educational component to this. And that's actually how Megan and Alan and I met, was a POSSE workshop, which I'm very glad. So the people that were doing this in the class, we knew because they had gone through the POSSE workshop. Let's see. I talked about this pre and post. The sample size, there were 115 pre and 94 post. So you're starting to get to the size where we can do a little statistical significance. Okay. We did use Mann-Whitney U for testing that significance because it is better, it's more appropriate for this sample size. To give you some idea, this is what we were looking at. We had software engineering courses, and what you see is URI is University of Rhode Island, so medium-sized institution. MOR is Moravian, very small liberal arts college. TCNJ, the College of New Jersey, sort of again a medium-sized. Grant McEwen, you guys know how big that is. That's a Canadian institution, isn't it?
College. Yeah, I don't know how big it is. I think it's pretty small.
Yeah, I don't think it's very big, yeah. And then Western Oregon University, which is, again, getting some reasonable size. Oh, and the other thing to note about this is, if you look at the numbers of students, I've been having conversations with UBC faculty throughout the day, and my upper bound for the limited class size limit is your lower bound for running class size. It's about 25. And so there is an outstanding question of, does this scale? Because most of what we've been doing have been in relatively small classes. Okay, so when we look at the demographics, we had 95% of students declaring some sort of computing-related major. We did manage to get 17% female. That's good because that gave us enough females so that we had some statistical significance when we looked at that issue. There were 8% that were not identified, and the rest were male. So when we looked at the results related to motivation and career, the motivation, we found a significant difference. Now what we're looking at is the difference between what they reported pre-taking the course to what they reported post-taking the course. And what we saw here was, yeah, students were a lot more comfortable with computing, right? And that's the sort of result you want to see. I had one other comment to make here. I don't remember. Okay. The other two things that happened that were a positive that we really enjoyed were, I'm confident about working with computing professionals. Students were clearly getting a better feel for how to work in a professional environment. And they felt more comfortable with the subject matter. Okay. When we looked at the learning that was involved, we found that students had a better idea of what software process was, how to use a software process to generate software, and the impact of complexity on the approaches that were used. And they came out relatively confident in their ability to go ahead and do this, that they were able to contribute. That's a positive. We did have a couple of negative responses. And the negative responses, okay, and these were both in the career section. One was that involvement increased their interest in computing. And that was a negative response. We think what's happening here is most of the students that were surveyed were seniors. They were already interested, and we were not going to see a big bump in interest because they were already very engaged. The more interesting one is, working on an HFOSS project has increased my confidence in my computing ability. Yeah, we think what's happening there is for most of the students involved, I can't say all because I'm not 100% sure, but pretty close to all, that was the first time they got to look at 500,000 lines of code, right? And they took one look at that and said, whoa, this is bigger than we thought it was. So we think that's part of what's happening here. We did get some interesting results for gender, okay? And in gender, here's where the woman factor came in. And this is important, and this is why NSF is interested. 17% in the US, across the US, undergraduate population in computer science, 17% women. That is lower than the number of women that are employed in tech fields, which is 25%. Which means that we've got women that are doing other careers and coming into technology jobs sideways without a CS undergrad degree. Yeah. So this is something that we are aiming at, and this is a strong reason why we're in HFOSS. Okay? I have other data, smaller data set, that shows that women show an increased ability in the management aspects of software engineering. Okay, the management aspects of software development. And this actually echoes some research that's done in engineering that shows that women tend to orient themselves and tend to be stronger in those areas as opposed to the more technical areas, I guess. Currently, so we've been doing this since 2009, and we've looked at a variety of things. We started looking at computer science majors. I have information technology majors. That's a different major in the US. And information technology looks at things like network security and more hardware level. Okay? And so we looked at both of those, and we didn't see any statistical difference between that. And we started looking at faculty and how faculty learn, because if I can teach a faculty to get students involved, now I'm spreading the word quite widely. And as we started to look at this, we knew this from the beginning. This is not easy, right? I've said some cool stuff. You know, students have had cool experiences. This is not easy. There's a learning curve involved, and there's a learning curve for faculty, and there's a learning curve for students, right? I think the learning curve's worth it, but it takes something to motivate a faculty member to get to the point where they want to involve students in an open source project. And we thought, I think we can help make this a little easier. So our current research is looking at defining learning pathways. And the learning pathways are pathways such that students can start as a freshman, and when they've gone down that pathway, they can make a contribution to an open source project by the time they're graduated. Doesn't have to be a code contribution. There's multiple pathways through that. Okay? So what we've started doing is defining what those things look like. What are they? And then we're going to map those to the ACM computing curricula guide, right? So that they fit in, so everybody can say, yes, this activity meets X in the ABET accreditation. And we're going to provide early learning activities. Our goal here is to scaffold learning in the freshman and sophomore years when students perhaps need a little bit more guidance in their learning, and then gradually remove the scaffolding as they become juniors and seniors. This is what a pathway looks like. It's just a series of steps. Okay? And it just defines what someone must do in order to make a contribution. Okay? So these are things like verify a bug, make a code contribution. Each step has two pieces to it. Okay? Each step has a step outcome, what the student should be able to do when they get done, and they have a process skill focus. For process skill, read business skill or soft skill. Communication, problem solving, okay, those ideas. We added those because, at least in the environments that we are working in, soft skills are a weakness. Okay? So we want students to gain both technical knowledge, but they need to be able to operate in a professional environment as well. Okay? In order to support the steps, we define learning activity, and each learning activity has a learning outcome and a process skill practiced. And when you put them together, it looks something like this, okay? Where you have your steps, and each step is supported by a learning activity. These are going to be published and available, and the activities are out there already. And the idea here is, now when a professor wants to do this, they can come and we can say, they can find it on their own, start here, do this, do this, do this. Here's a pathway to a contribution with the activities that students can do so that you don't have to invent them, including rubrics. So first the first paths that we defined are things like contributing codes, working on defects, documentation, okay, release packaging, demo server, maintaining a demo server, things along those lines. We're currently using something that looks a little bit like a use case to describe what these things look like. This is the one for verify a bug. Okay? So the end contribution is the bug is verified. Okay? The prereq is what do students need to know before they get to this step? Before they get to this step, what do they need to know in order to take the next step? An example step here to verifying a bug would be to reproduce the bug, because in order to verify it, you have to reproduce it. Okay? There would be an activity associated with it that asks the student to install the application and reproduce the bug. And then the context is, how would you use this? Some instructors, let me back up. Involvement in a real-life project has some risk in it. And some of the risk is the community doesn't behave exactly in the way that you want it to, or even that you expect it to. So when instructors first get started, using a canned project that they have control over, something that they can control, might be a good first step to doing this. All right, let's see. Let me pause here and see if there are questions. Got 45 minutes? Yes?
So for the gender issue, are you tracking to see if involving women in this project, do you attract more people in this project? But do you think HFOSS?
Is the question, am I tracking if involving more women attracts more people to the project? Is that the question?
I said it wrong, I guess. I'm just wondering if, because you were saying the motivation of doing good, and I was wondering if having that as motivation attracts more females to working on this kind of thing.
We're trying to do that. That's a really difficult thing to measure. Yeah. The other thing that's really, that isn't on the slide, but thing that we're trying to measure is what actual learning, right? What the work that we've done is not measuring student learning, it's measuring students' opinion of their learning. And we haven't tackled the, what do students actually learn?
My other question was, have you interviewed the students for the survey? Because you're trying to interpret what they're reading, but have you actually gone in and interviewed?
That's on the list to do. That's on the list to do. As is interviewing the faculty members. What are their experiences? What worked for them? What didn't work for them? What could we do that would help them? Yeah, there's a lot of work to be done. So, other questions? Yes?
Your hypothesis age 9, where you showed that students had a negative response on being confident in their computing ability. Had they had prior experience where they had to read a corpus of code that's within a factor of 3 or 4 to the size of the ones they're looking at here?
I can't, so the question was, had students had practice prior to this experience reading a large corpus of code?
Right.
So I cannot say that for sure. That's not a question that we asked. And given that we were dealing with a number of different institutions, I don't know the exact answer to that. I can tell you anecdotally, no, that they hadn't done that. So you're right, some of this is the first exposure to a large body that has significant complexity.
In which case this might actually be a positive, if you confirm that, this would be a positive outcome, because it's probably better to get that experience on a project like this than on your first job.
Exactly, definitely a positive while they get that exposure while they're in school and they can ask their questions as opposed to getting slammed with it when they enter their first job, yes? Yes. All right, other questions? Yes?
I'm still trying to understand, like, how this is fitting into the context of a course or say their degree. So is this a course in software engineering hyphen HFOSS basically, and so the whole focus of that software engineering course is on HFOSS, or is it a module within a course? I know you said some of these things take 15 weeks, which suggests it's spanning the full course, but I'm just not clear.
Good question. Question was, how is this related to the course, or how does it fit in a course? We've been looking at a variety of models as to how to fit it in a course. The big picture answer is what we would like to do and what we're trying to do at Western New England is introduce some of the initial HFOSS core pieces, things like Git, as freshmen, in the freshmen, so that by the time they get to the point where they can interact more with the community, they've got sort of that tool learning done. The examples that I showed you are typically from a 15-week senior software engineering course. And my approach to this, right, we don't have enough room in the curriculum, right? We need like more room or less stuff to teach. So I was faced with the issue of how do I run a software engineering class and still do this HFOSS stuff? And what I did was I have a template of a set of IEEE-based templates. So IEEE's got SRSs and software design specs. They're pared down and they're annotated with information that needs to go where, and they have a rubric. There's no open source project that I know of that I have encountered that has a document called well, there is one, Mousetrap, because we made it. But a requirements document it doesn't exist. Design documents typically don't exist. Testing sort of, kind of, maybe exist. So my approach was to take a typical software engineering course, you're gonna do requirements, design, implementation, and use as the project the HFOSS project. And so we created requirements for an existing project. I had them extract the design. That's a fun one. Does that answer your question?
Yeah, I think so.
Okay. Yes?
Can you talk to, maybe without identifying the groups, but some of the negative experiences you seem to be skirting around with interacting with these open source communities? Like, what would that look like? Or,
So the question is what went wrong, I think, right? Yeah, okay.
Communities that weren't so receptive, perhaps.
Yeah. So in general, I have found my experiences to be really, really positive. The downsides are it takes time, and you're interacting with a community, and it takes time on the part of the professor, because From an instructor standpoint, I am not taking 20 students and dumping them on an open source project. They will hate me for the rest of my life and their life, right? So it takes time for me to learn the community. I do some interacting with the community and indicate, look, I have these students. Are you interested in having student contributions? The students, there's a steeper learning curve there, okay? Some of the things that I have found that are truly negatives as opposed to just time sinks. I did have a project, the project that I mentioned earlier, that we were doing. I think it's Empathy is the GNOME web browser, and we were going to do plugins. And I got 6 weeks into a 15-week semester, and the community turned to me and said, "Oh, by the way, we're reworking the software architecture. We're not going to use plugin architecture anymore." And so I said, "Oh, okay." But it's all open source. All the artifacts are there. I said, okay, we're not changing an architecture 6 weeks into a 15-week course. We just continued on our way. We didn't have as much of the support as the community as I would have liked because of the change. At the same time, it didn't impact our code. It didn't impact all of the rest of the stuff was there. And there was some possibility that the core functionality of the plugin might be accepted into the larger group. I have had. The other somewhat downside is I've had students that are resistant, not many. I can think of 2 in all of the classes that I've taught, but students that just did not want to engage with the community, did not want to participate, did not think that it was a good idea, that they were talking to these groups of professionals at all. Right. And that's just, I just isolated them and put them on a group by themselves and a team by themselves and said, sink or swim, this is what you got to do for the class. Sorry. Those are about the 2 main downsides I found. I can't say I've had any real, train wreck experiences. You do learn a lot about how to grade. Grading was an issue the first couple times around. Yes?
How did you manage milestones? Because you're kind of subject to the pace that the community respond.
Yeah, good question. How do I manage milestones? A couple key tenets when you're involving students in open source projects. One is never pick anything on the critical path, right? They won't let you. You could try it, but they won't let you work on it. And you can work on it. There's nothing that says you can't. But the likelihood of you working on it and being accepted, low. And then what it turns out to be is, okay, so you're working on something related to adding something to the tooltip, that example. That, if it doesn't go out on this release, it'll go out in the next release. So there's not a concern there. The other thing is, when I structured my course, most of the grading was done on process, not product. I did not make a grade contingent on the fact that they got any code accepted, or that they got any contribution accepted. Because I was less worried about the acceptance, I was more concerned about the learning and the involvement in the open source project. So what I did was I started out with something that we call a FOSS field trip. And I said, okay, students, here, you are to go. I gave them a whole list of questions. It's on, and I'll show you the link to the course materials. Here's a list of questions. I want you to blog. Give me 2 pages on what you found looking at this project. And that was the introduction to the project. And it's graded, right? So it's a deliverable that they need to provide. We had them do requirements, and the requirements was a pretty big document. It's an IEEE spec, it would come back 25, 30 pages. They had to have questions answered from the community in order to complete that document. I did not just say, go ask your questions to the community. What I did, because it was still early in the course, was I said, okay, come up with a list of questions, and I had them in teams of 4. And there were two or 3 teams. And I would say, come up with a list of questions. And each team would come up with a list of questions. We would bring them into the classroom and spend class time coming up with 1 list of questions. Some of the questions that we could answer, I'd walk them through. This is how you would get the answer to this question. Or this is an ill-formed question, I don't know what you're asking. We would then come up with a small list of questions that we really didn't know the answer to, and we couldn't find the answer to Googling. And I would then, depending on the class, either turn the questions over to the community or have the students ask the questions of the community and get the answers back. In testing, when we did testing, They had to come up with a test specification. We took the results of the test specification, found all the bugs, and did the same thing with the group of bugs. So we had a final total group of bugs. And then I just made an assignment. I gave 2 bugs per student and said, go, your job is take those 2 bugs and create a bug report on the issue tracker. So a combination of larger software engineering related documents and smaller sort of little mini bite assignments. That answer that question? Okay. Other questions? Okay. All right, I have 5 more slides, or I can quit now. Pardon?
We're good.
We're good? Okay, so let me show you the, we're good for me to quit?
No, keep going.
Oh, keep going. All right. All right, so how do you do this thing, right? How do you get started? Well, the first thing you do is come up with a short list of possible projects. This is not as simple as you might think. Finding a good project is one of the key hurdles, right? It's one of the key things that it can be difficult from an instructor's perspective. I got lucky when I started with Sahana. It had a minimal database attached to it, and it was a simple design. Things like the Caribou on-screen keyboard, that was one of my early projects that was, again, lucky. It was Python code. I had no database. I had a really simple UI. There wasn't a lot of inherent complexity there. Start with a short list. I've got some there. OpenHub.net is a way to search all FOSS projects. And then figure out, can you find the page, the project page? Can you figure out how to communicate with the community? Are there mailing lists? Do they use IRC? What documentation is available? Is there a roadmap? OpenMRS actually has something called a roadmap, and it tells you what's going to be in each of the releases as you go forward. Who are the committers? The committers are the people that hold power. Who are they, right? What do they use for bug tracking? How up to date is it? What are the open bugs? Where is the code? And can you get at the code? And how easy is it to get at the code? And what are the releases planned? So do this cursory look at the project. And I have students do this too. So this applies to both instructors and students. And then think about the kinds of contributions that you want your students to do, right? And a quick look at the bug tracker should give you some idea whether the needs of the community fit your learning objectives. You're probably never going to get a perfect match, but it will at least give you an idea. Note that bug trackers keep open bugs and they keep solved bugs. And so one exercise that's really helpful is find a bug that has been recently solved related to something you might do in your class, and then go back trace how it was solved. Because it doesn't usually happen that somebody posts a bug, somebody provides the code for it, and it's perfect, it's done. How often does that happen? You're shaking your head. No, it never happens. What usually happens is someone posts a bug, someone comes along and says, oh yeah, that bug's in Ubuntu. I tried it on Fedora. Look, and they post something else and they say, oh, I had the same thing happen in Fedora. And then somebody else comes along and says, yeah, and it also does X, Y, and Z in this platform. And then someone comes along and says, has anybody looked at this library as a solution for it? And somebody else will come along and they'll say, yeah, I looked at that, but it didn't work. I'm looking at this library over here. And so there's this whole conversation that happens. Eventually, somebody comes up with a solution, and then somebody called the committer actually accepts the solution into the code base. It's that sort of a process that tells you how what your process is likely to look like. I lurk, then. Once I think I've got a reasonable project, I hop on the mailing list, and I hang out there, right? And I read logs for months back. Again, it is all public. And this is the point at which I start talking to my students about, be careful what you say in the listserv, because if you're rude, you've just made a major error in your professional presence online, okay? And then I joined the IRC. IRC is Internet, you know what IRC is, yes? Yes, no, okay. So I joined the IRC. I've got IRC open now, actually, sitting back here. If somebody wants to talk to me, they just ping my name, it comes up. It won't show in presentation mode, and I know to pay attention. Oh, somebody's got a question for me. I'll go 3 weeks and nobody will have a question, or I'll have 3 questions in a day, right? So it gives you immediate access to your community at a very low bandwidth. Figure out when the meetings are and hang out in the meetings. Lurk them when the meetings happen. Once you're comfortable, once you think you've got a reasonable community, introduce yourself and explain who you are, okay? And then identify what you or your students would like to contribute to the project. You don't need to say details, but if you think you'd like to, for instance, work on documentation, okay, maybe do some testing, something like that, introduce yourself to the community that way. And I typically, at this point, if I know that I'm going to introduce students into this community, I give the community a heads up as to what to expect. I have a class of 15 students. They're going to be able to work for 15 weeks. They come in, they're seniors, so they have some knowledge of computing, but they're not going to be expert coders. And I just give some parameters so that the community doesn't go, who the heck are these people? Okay. Remember, the goal is not to find a project. The goal is to contribute to the community. You may find the best project out there, and you may have the coolest innovation to that product, to that project. If the community doesn't want it, they're not going to accept that contribution. Now, that doesn't mean that you can't suggest a contribution. Open source loves people to come along and say, hey, what about this? That's great. But if you say, hey, what about this? And they say, nah, we looked at that. We don't want it. Don't head in that direction. The community's not going to help you. They're not going to support you. They have better things to do. They want to focus their energy on getting the product out that they want. Okay. Then find a small task you can accomplish, right? Identify who's responsible for it. Get it in. Fix a typo. Change a background color, right? Do something not big. Don't aim for big. Start small. This will get you a reputation in the community. It's how your students get a reputation in the community. Open source projects are meritocracies. They are based, you are assessed by what you can do, not who you know. Here's a fun story. Greg de Koningsberg, know him? No, worked at Red Hat. He was working on a project with Sebastian Dezalis. Sebastian is now a PhD student at the University of Kent. So this is a relatively old story. Sebastian and Greg were going back and forth, had never met face-to-face, communicated only electronically using IRC. And Greg thought it would be good if Sebastian would come from Germany, where Sebastian was living, to a local conference that they were having. I can't not remember what product they were working on. So he emails Sebastian and says, hey, Sebastian, Red Hat will fund you to come to this conference from Germany. Are you interested in coming? And the response he got was, I have to check with my mother. Sebastian was 15 years old at the time. Right, it doesn't matter what PhD you've got at the end of the name. The issue is, can you perform in the community? Are you contributing to the community? Okay. All right, so quickly, challenges for the student, there's learning curves. New tools, the processes, just that whole issue of how do you handle the size and complexity of a product. We have coined the term productively lost. The idea that, yeah, you're going to be handed 4 million lines of code. You have to learn how to navigate in there. There are milestones. There are signposts to help you, and the community will help you. Okay? And students learn a lot about professional behavior and independent learning. Instructors, there's also a significant learning curve. Okay? There's a lot less structure and control. When I started teaching adult working professionals, and I had newly graduated with my PhD in hand, and I was all ready to teach my first class, and I had my first class of people that were dressed better than I was, working professionals, and I went around the room, and the guy in the back said, and this is a software engineering class, my name is Guy Vandervoort, and I've been doing software engineering for 20 years. And I looked at my little PhD and thought, I am in trouble. And then the guy in the front said, my name is Ryan, whose last name I can't remember, and he said, I write the timing software that causes the torpedoes to fire at Electric Boat, and I hope you can help me. And I went, oh, I am in such trouble. I'm in such trouble. So I was never the expert in the classroom when I started teaching. I was always the person going, so the studies show that if you that if you do code reviews, your code is better. And they would look at me and they would say, my manager won't let me do code reviews. So we had this, so I quickly learned to learn alongside of them. And I quickly learned I was not in charge. If you are coming from a culture as an instructor where you're supposed to be the boss, this can be so intimidating, right? Because you're not the boss, okay? There's less structure, there's less control. And the interaction with the project community. Oh, let me talk a little bit, you guys, FERPA, is FERPA a US thing?
We have a different thing.
You have a different, okay, we call it FERPA in the US. It's this, you cannot let student work with grades be made public, right? So the one comment here is your mileage is gonna vary. You need to check this with your institution if you're gonna try it yourself. All right, oops. Talk a little bit about POSSE. POSSE is the professor's open source software experience. We are still running these. We are hoping to run our next one at Google in San Francisco, yeah. And we occasionally have POSSE alum come back. Yeah, there you go. So we are running these. Google has kindly, not the Googleplex, but the San Francisco office has offered to host this in April of next year. If you know of people, let me know. I'd be happy to have instructors. We do need to have instructors, and there's a limit on what we can do from Canada, isn't there?
Yeah, I think I need to pay for my own travel because it's NSF.
Yeah, it's NSF funding now that I think about it. But Megan came, we fed her. Right. But if you can get there, we'd love to have you come with us, okay? We are hoping to do, Google may also fund a POSSE Europe. We're hoping, we're not sure, we're waiting to hear about that. If we do, that one's open. All right, so just in conclusion, the learning opportunities are vast, right? And they range across a whole variety of different kinds of things that students could and should be learning. Huge opportunity for things like networking, okay? Oh, and students put this on their resume and they are instantly employable. So it's a huge boost. There's your resources. The FOSS to Serve link is where the teaching activities are, and that's where the research stuff is, and it is a poorly organized wiki, so I will apologize in advance for that. Teachingopensource.org is a site that I am currently redesigning with Red Hat support. It currently says it's locked down. That should be up and running again by the end of December, we're hopeful. OpenHub.net is the Black Duck site where you can go and search for projects. Questions? Yes.
So you focused a lot on the computer science aspect of things. What about open source as sort of an interdisciplinary thing with other units on campus?
So the question is, what about open source as an interdisciplinary area of study? We're looking at that. We're just starting to look at that. It's taken us a fair bit of time just to get it up and running successfully in computer science. It's open. Oh, I have a friend, Sarah Jane Terp, who used to work for the United Nations in the area of data analysis. And she now works for, I think, something. And she's big into open data, and that's one area that we may look at next. Other questions? Yes?
Yeah, so you mentioned the challenges for instructors is that they have to learn a subset of skills for the students. Have you considered doing any studies of what the impact of that is? Because a challenge in academia is it's quite possible to be a faculty member and never deal with a software project that's bigger than a homework assignment or something assigned for a class project. So are there benefits to faculty members of being engaged in this?
Yeah, my PhD dissertation involved 20,000 lines of C++ code, and no, it was not under source control at all, ever. So we have a study. I have IRB, Institutional Review Board. You have IRB? Yeah, I have IRB approval to do faculty interviews for POSSE alumni, so people that have been doing this. So it's on the list of things to do. I need more time. Other questions?
This might be a little heretical, but would it be easier to get a good project, a project that sort of ticks all the things you mentioned earlier, if you dropped the H from HFOSS?
So the question is, could I drop the H from HFOSS and find a good project? Or were you asking, is it more easily?
Scouting projects.
It would give me a larger pool to draw from. I think it would. My funding wise, I can't go there. It's all about the community. And there are a lot of projects out there that may have good features related to size, complexity, and so forth, that have a community that's not supportive of students. And one of my concerns is to make a project that supports student learning. So there's probably lots of projects out there that are like that, and there's probably some in games that students would find my students always ask that, can I work on a game? Other questions? Thank you very much, I appreciate it.